Hello students, this is lesson U4A03a. By the end of the lesson, you should be able to say I can use properties of sides, angles, and diagonals to identify a rectangle. So for the past couple lessons in this unit, we've been talking about polygons, and then more specifically quadrilaterals, and then even more specifically in the last two lessons, we talked about a very specific kind of quadrilateral, which is known as a parallelogram. So in this lesson, we're going to be talking about another specific kind of quadrilateral, which is known as a rectangle. Now, a rectangle, now I know what you guys are thinking. A rectangle, like we know what that is. We knew what that was ever since entering pre-K, right? I have a young daughter. She is entering pre-K at the time that this video is made. So she already understands what a rectangle is compared to, let's say, another shape that's not a rectangle. If I were to ask her to identify which one's a rectangle, she immediately points to this and says that that's the rectangle. So intuitively, we have an understanding of what a rectangle is, and that is all the angles here have to have, all the angles in the rectangle have to have these straight corners, right? My young daughter doesn't understand what a right angle is, but you guys do, okay? A rectangle has to have all four angles that are right angles. Well, we're going to do better than this because, you know, we're in high school geometry. We are developing our ability to communicate, especially in a more abstract sense. Okay, so here with this rectangle, with a rectangle, okay, I want you to, let's observe what's happening really, okay, and how we can maybe classify it and look at the shape a little differently. Notice, okay, that these angles over here that I am pointing to right now, those are 90 degrees, and when added up together, they're supplementary. What do we know about consecutive angles being supplementary again? That's right. If we have consecutive interior angles are supplementary, then we're going to have a pair of sides are going to be parallel. And then similarly, okay, I can look at these pairs of sides. Let's do it in green. Okay, so these angles over here are also supplementary. So therefore, these two sides are also going to be parallel. So inherently a rectangle is in actuality a parallelogram. It's a more specific kind of parallelogram. It's a parallelogram with at least one right angle in it. And notice my choice of words here. It is a parallelogram with at least one right angle because if in fact one of the angle turns out to be a right angle, then just by the very nature of parallelograms, where consecutive angles have to be supplementary, where opposite angles have to be congruent, all the angles inside of the parallelogram therefore must be right angles. So, you know, the choice of words are very, very precise. So, which brings me to the very, very first property. In order to show that a quadrilateral is in fact a parallelogram, we first need to show that it's a parallelogram, and then show that one of the angle is a right angle. Again, to show that a quadrilateral is a rectangle, we need to first prove that the quadrilateral we're dealing with is in fact a parallelogram with at least one right angle. The next property is this, okay? And that is if a parallelogram were to have congruent diagonals, then the quadrilateral we're dealing with will be a rectangle. And this has absolutely no discussion of the angles whatsoever. There's no discussion of whether the angle should be a right angle or not. And this is the higher level thinking that as high schoolers, okay, we should have an understanding of regarding the shape. So a rectangle is in fact a parallelogram where the diagonals are congruent to one another. Okay, so with that understanding, well, why is that even true though? Well, let's just take a moment and think about this and reflect on this. If I have this parallelogram and I'm telling you, okay, that the diagonals are congruent, let's just say hypothetically, I'm calling this angle over here A. The other angle on the other side, therefore, must also be A, because I'm dealing with an isosceles triangle. I'm dealing with an isosceles triangle here. Can you recognize that this is an isosceles triangle? Because those the two diagonals there, those two are congruent. And similarly, okay, notice this side BC, is congruent to side AD, yeah? So therefore, these triangles over here that are opposite of one another, they too should also be congruent, right? So corresponding parts of congruent triangles, therefore, must be congruent. So therefore, if I call those angles A's, therefore this must be also angle A. And then the same argument could be said about the other two triangles over here. I can call this angle over here B, therefore the other angle must also be B. On the right side, that triangle there should also be congruent to the triangle on the left. So therefore I'm going to call this angle B and this angle B as well. What do I know about all the angles in a quadrilateral? What do they have to add up to? That's right, it's 360. So I can say 360 is equal to, well, how many A and B's do I have? It looks like I have 4 A's plus 4 B's. If I divide both sides by 4, what will I end up with? I'm going to end up with A plus B is equal to 90. Look at that. This is not black magic. What I've just demonstrated to you is that each of the corners must measure 90 degrees because each of these make up A and B. So therefore, each of the corners must equal to 90 degrees. And what do we know? Hey, it's a parallelogram with one right angle. So you see how I'm going in circles here? If the logic, okay, if I have a parallelogram with congruent diagonals, that is actually sufficient to prove that this quadrilateral is in fact a rectangle. Okay, let's take a look at some examples now. So now I have ABCD where rectangle, I'm telling you that it's a rectangle, and I'm asking you to find out for me what is side AE, CE, BE, and DE. So let's look at this. I know that AE is equal to 2x plus 5, and CE is equal to y plus 2, and I know that BE is equal to x plus 7, and DE is equal to 2y minus 5. Pause the video for a moment to see if you can figure this out on your own. So hopefully you had some time to think about this. Let's take a look at the information. So I know that each of these sides here, because in a rectangle, all the diagonals are congruent and the diagonals bisect one another. So therefore I can say that AE is going to be congruent to CE, which is going to be congruent to BE, which is also going to be congruent to DE. So because I know each of these things are going to be congruent, I can therefore say AE will equal to BE. So I can say that 2x plus 5 will equal to x plus 7. Subtract both sides by x and subtract both sides by 5. I know that x will therefore equal to 2. Because x is equal to 2, I can then figure out what the length of AE is. AE therefore has to equal to 9 because it's 2 times 2 plus 5. Same thing could be said about BE. BE must also be 9. And then I can solve for what CE is, but you know what? I don't even have to solve for what CE is. I already know what CE is going to equal to because this is a rectangle after all, right? And because they are all supposed to equal to the same thing, that all of these should equal to 9. Let's see if that's actually the case here, right? If I have 2y plus or minus 5 is equal to y plus 2, if I subtract both sides by y and then add 5, I end up with y is equal to 7. If I substitute y is equal to 7 into this equation, yes, indeed, I will end up with 9. But again, I didn't really need to do that because I already know it's a rectangle, so CE and DE and all of these partial diagonals, parts of diagonals, should all add up to 9. Let's take a look at another problem. So again, I'm telling you that this is WXYZ is in fact a rectangle, and I'm telling you that angle W is equal to 7x plus 20, WZ is equal to x plus 20, and then ZY is equal to 3x plus 10. So, and I'm telling you this because, well, is it well, pause the video, see if you can figure this out on your own first, and then we'll get back together. So this problem was actually designed to mislead you just ever so slightly, okay? You have three different expressions involving x, okay? As a student that just follows instruction, okay, you know, whenever you see an expression involving x, you have one of two things: you either add them together, or you set them equal to one another, okay? And students who go through math without thinking, okay, will probably just, you know, do one of those two things without even thinking. So I hope that you guys are not falling into one of those into that category where you're just following directions all the time and that you're thinking for yourself. Looking at this, okay, yes, I'm given three expressions all involving x. However, angle W, okay, I'm telling you is equal to this thing. But we know what angle W should equal to because this is a rectangle after all. Angle W has to equal to 90. So that is what we're going to do to solve for what x is. So 7x plus 20 will equal to 90. Subtract both sides by 20, and then divide by 7. I'll end up with 7x is equal to 70, and x divided by 7, I'll end up with x is equal to 10. So knowing that x equals to 10, I can then substitute those values into there to solve for what WZ and ZY is. So we're not equating anything, these expressions which involve x together, but in fact, the only way to solve for what x was to use angle W. So here, if I substitute that in, WZ will then equal to 30, because x plus 20, and then ZY will equal to 40. The question is to solve for WZ, ZY, WY, WX, and XY, right? So wait a minute. So WZ is 30, ZY is 40, XY must be 30, and and WX must also be 40 because opposite sides of a rectangle are congruent. We need to now also figure out what is WY and ZX. Well, actually, no, we only needed to figure out what WY is because that's what it says over here. Okay, so to figure out what WY is, now looking at this, okay, I'm dealing with a right triangle where this is 30 and this is 40. Immediately, what should jump at you is this is a Pythagorean triple. The third side, therefore, has to be 50. If you didn't recognize this, you can, of course, always resort to using the Pythagorean theorem, and you will end up in the same exact place. However, I do encourage you to try to recognize these Pythagorean triples as it becomes super handy in problem solving. And that's it.